7. And this last part of chapter 7 is titled Properties of Trapezoids and Kites. Okay. Still dealing with quadrilaterals, my friends. Okay. But the first thing we want to look at is a trapezoid. You guys have heard of trapezoids before, right? You know, the parallelograms, the squares, the rhombus we've been looking at, they've all been parallelograms. Two pairs of parallel sides. But today we're going to start looking at trapezoids and kites. Guys, trapezoid, let's start right there. Trapezoid, first of all, is a quadrilateral four-sided figure when it has exactly what? One pair of parallel sides. It says the parallel sides are called what? Bases. Base angles are two consecutive angles who coincide with the base. All right. So for instance, right here, kids are talking about this base right down here. All right. Base angles would be down here. I'm sorry. I don't know why that's moving around. Base angle here and here. All right. And then, or the other two angles that could be common with a base would be here and here, because these two sides up top and the bottom are my parallel sides. Okay. What do they call the legs of a trapezoid, kids? What are the legs of a trapezoid? Maybe that's a better question. Those two sides that are non-parallel. So in this case, the legs of the non-parallel sides would be AB and what other side? CD. Okay. All right. So how many pairs of parallel sides in a trapezoid? Okay. One pair, and the two parallel sides are called bases, and the non-parallel sides are called the what? Called the legs, right? Okay. Not that we're eating turkey legs at all this week or anything like that. Okay. By the way, I heard I have to deliver pies to your place. Is that true? Don't know. I don't know if they'll get delivered. If you're putting me in charge of delivery, they may not get delivered. I may just keep them. I don't know either. I don't know either. Should I take a big bite out of it and then give it to you? You don't care? You'll still... You're not? You might change your tune if you have Mindy's pie. Okay. Guys, isosceles trapezoid. An isosceles trapezoid is a trapezoid where... What are you doing, kids? So notice these two non-parallel sides right here, the left and the right, okay? Even though they're not parallel in an isosceles triangle, these two distances will be the same. Guys, you've heard of isosceles triangles before. How many sides are equal in an isosceles triangle? 2, you bet, okay? Okay, we're going to talk about the mid-segment of a trapezoid. The mid-segment is the segment that connects the midpoints of a trapezoid's leg. So take a look right here, kids, here and here. Aren't those 2 points the midpoint of each leg right there? So that mid-segment is the connection of those 2 points that are midpoints on each leg of a trapezoid, okay? So I think you've got some pretty good general knowledge of trapezoid. I think we just want to clean up some of the definitions in terms of what applies where, and I think those do a good job up there in the vocabulary, okay? Guys, another quadrilateral that's kind of unique is called a kite. The kite's a quadrilateral with, okay, I'm going to highlight this, and you might want to underline it with, it says 2 pairs of what? Consecutive. Okay, when I say consecutive, they're right next to each other. So notice this side and this side. This is 5, and this would be 5. Aren't those 2 sides equal? You would say, yes, those tick marks make them equal. But are they opposite of each other, or are they right next to each other? Right next to each other. So on a kite, the 2 sides that are equal are right next to each other. And then this might be a situation where this is 12, and it would make this 12. So don't you really have 2 pairs there that are the same length right next to each other? Okay, so that's what that means, all right? Kids, we need to recall some formulas, okay? One formula is called the slope formula. This is what you need to know. M is your slope. It's equal to y2 minus y1 over x2 minus x1. You guys probably know slope by definition a lot. Rise over what? Run, okay? Another one that's going to be new for you today maybe would be midpoint formula. Midpoint formula is right here. Your midpoint is always x1 plus x2, the first x value in a point, plus the second x value in a point divided by what down here? And then comma, your y values added together and divided by, guys, if I asked you this question, what's the midpoint of 10 and 6? You would say what? Where's the very middle of 10 and 6? How much? 8. What's 10 and 6 add up to? Cut that in half. Puts you right at 8, right? Okay, so the midpoint's just the average of the 2 points, if you will. All right. Guys, remind me if you've seen distance formula before. Have you seen this formula before? Okay, distance formula is something else we're going to have to recall. The distance formula is going to involve 2 points, x1, y1, x2, y2. Your distance is defined as the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Kids, I will tell you this. Have you heard of Pythagorean theorem before? What's that formula? This is nothing more than a fancy formula for the Pythagorean theorem. This is basically a squared plus b squared equals c squared, just in a different format. Okay. All right. So we've got some things there. Let's go on to page 2, see what we can deal with here. Oh my gosh, there's more. Holy cow. Let's talk about example 1, kids. Example 1, identifying a trapezoid in the coordinate plane. Show that ORST is a trapezoid, then decide whether it's isosceles. Okay. All right, kids, how many pairs of parallel sides does a trapezoid have? Okay. If something's a trapezoid, we have to show, and I'm going to write this down right here. If something's a trapezoid, you have to show that exactly. Oh gosh darn it. You gotta show it exactly one pair of sides is parallel. Okay. And in parentheses right here, kids, here's what I'm going to tell you. If 2 sides in a coordinate plane are parallel, their slopes have to be exactly the same. Okay, so I'm going to write this right here. We got to show that exactly one pair of sides is parallel by showing that they have the, what did I just say, kids? Oh, I'm freezing up here. Probably because I wore Mr. Bumble today. It's freezing. Now, kids, let's just first of all take a look at this. What 2 sides appear to be parallel? RS and OT. Okay, guys, let's just look at the slope of RS. In a coordinate plane, we can simply count. Okay, from R to S, what's the rise distance? And what's the run distance? Okay, so do you guys agree that the slope of, I'm going to write slopes right here, RS rise 1, run 2, wouldn't that be a slope of 1/2, kids? Okay, let's look at that other one, O to T. Let's look at O to T. Kids, to go from O to T, it looks like I've got to rise 2 and run how much? But what's 2 over 4 reduced to? Okay. So we've got those slopes, don't we, kids? So do we have at least one pair of parallel sides? Is it possible that 2 pairs might be the same slope? How does it look like these are even close to the same slope? You can say no. What's the rise distance for this one from O to R? 3, and then over 0. Guys, 3 divided by 0 is undefined, isn't it? Okay. How about the slope of this other one right here? Looks like you'd have to go down 2 and over what? Okay, so I'm going to do this. The slope of, I'm going to say the slope from O to R. That's undefined. And then the slope from S to T, that's negative 2 over 2. What's negative 2 divided by 2? Negative 2 over 2 would be negative 1, right? So that slope's negative 1, okay? So kids, how many pairs of parallel sides do we have? Yeah, your pair of parallel sides is right here. You got this one side RS parallel to OT. So I'm going to say since RS and OT have the same slope, then those 2 sides are what? Can I say those sides are the only pair of parallel sides? Therefore, this is what? Okay. Now, the next thing they said is determine if trapezoid is what kind of trapezoid it is. Well, it's pretty easy to count this distance right here from R to O. Count that leg right here. Don't you have a leg right here? What's that leg distance, kids? Okay. Let's do this distance right here. Okay, isn't this just part of a right triangle? Isn't this part like right here in blue? Isn't that part like the hypotenuse in a right triangle? So that part in blue, I could do a leg of 2 and a leg of 2. Isn't this distance over here on the right 2? And this distance over here on the top, isn't that 2? You guys remember Pythagorean theorem? If I go 2 squared plus 2 squared, what's 2 squared? 4 plus another 2 squared would be what? Okay, so this distance right here would be the square root of 8, isn't it? Okay, is the square root of 8 equal to 3, kids? So is this side right here, is this side from O to R the same as this distance from S to T? Are those two distances the same? Okay, so I'm going to say down here, second part, I'm just going to maybe write part 2. The distance from O to R does not equal the distance from S to what? T. So isosceles or not isosceles? Oops, I spelled that wrong. I forgot the S. This is not isosceles. Okay. All right, so we kind of understand what an isosceles trapezoid is. So let's talk about, in that case, it wasn't an isosceles trapezoid up there in example 1 because the legs weren't equal, but it was a trapezoid because you had one pair of parallel sides. Let's talk about some isosceles trapezoids, kids. Right? First one is called the isosceles trapezoid base theorem. It says if a trapezoid is what? Okay, so the legs are the same what? What's true about A and B triangles? And B and C are what? Okay. Same thing, isosceles trapezoid base angles theorem. If a trapezoid has a pair of congruent base angles, they're saying if this angle A and B are equal down here and BC is parallel to AD, what must be true about A and B? And then what would also be true about B and C then, kids? They would be the same. Okay? Another isosceles trapezoid theorem involves its diagonals, to which it says a trapezoid is isosceles if and only if its diagonals are what? Meaning that BD would have to equal what, kids? Okay, so I'm just going to make this little note right here. So BD would have to equal or be congruent to, can I say AC? Is that okay, kids? Okay. So let's use those isosceles theorem. I should say, let's use those theorems about isosceles trapezoids here to answer some of these questions. Okay. My friends, in example 2, it says the stone above the arch in the diagram is a what? It's an isosceles trapezoid. So we want to find the measure of K, M, and J. All right, so I'm just going to write it this way. Okay, first of all, we know angle L is what, kids? Okay, so angle L has to match what angle then if this is an isosceles trapezoid? Okay, base angles would have to be the same, right? So 85 would have to be here. So what's that make angle K, kids? Now, aren't there 360 degrees in a trapezoid? Okay, what's going to be true about angle J down here and angle M? They're going to have to be the same, okay? Well, L and K are 85, aren't they? Kids, how in the world am I going to find the measure of angle J and the measure of angle M then? So you're saying 85 and 85, that's 170, and subtract it from how much? So you're saying, well, Parson, collectively here we have 170 degrees from 360, right? Oops. Means there has to be a remainder of 190 degrees between these two congruent base angles, right? Anybody know what 190 cut in half is? $95. Very good. Very good. So the measure of angle J is 95 degrees. And the measure of angle M is what? Guys, when I write this measure of angle M like this, you know what I can think about? All I can think about? What are your favorite kind of M&Ms, kids? I'm a peanut butter guy myself. Really? The peanut M&Ms? Really? I love peanut. Listen, they don't make a bad M&M. Okay. All right. But I'm peanut butter. I like the caramel ones too. Okay, guys. Example 2. Got everything down? Any questions to this point? Okay. Isosceles trapezoid theorems. I think you're in pretty good shape here. Okay. Let's take a look at this next theorem. This talks about the mid-segment theorem. It says the mid-segment of a trapezoid is parallel to each base and is the length, its length is going to be 1/2 the sum of the lengths of the bases. So for instance, kids, if I said this, if I said A to B was 8 up here, and I said D to C was 16, wouldn't M to N right here be in the mid-segment? Wouldn't that have to be the average of those two? What's 8 and 16 add up to? Half 24? What would the distance of M to N have to be here then, kids? Okay, so let's just talk down here. Here's an example, all right? They tell you that P to Q in this trapezoid is 12, and S to R is what? So you're going to take 12 plus what here, kids? And then cut that answer in. Pretty simple, isn't it? Guys, what's 12 and 28 sum up to be? 40 divided by what? Is? I don't know how to make that any easier on you guys. I think you get it. Give me your little bobblehead right now. Yay or nay? Good? Okay. That's what we should do, kids. I should get a little bobblehead of every single one of you. And then if I want to know if you're on board with me, you can put your little bobblehead on your desk and you could push it so it goes. Or you could push it so it goes. Should we do that? You guys, and then you could get to keep your own bobblehead after the school year. What do you think about that? We could have a Reese bobblehead and a Keegan bobblehead. What do you guys think about that? That's a pretty good idea. I might make some money off of something like that. You know what I'm saying? Oh, it'll be the next coming of the fidget spinner. Guys, let's move to example 4. Again, this is about what right here, friends? Okay, using the mid-segment in a coordinate plane. It says find the length of the mid-segment YZ in the trapezoid STUV. Guys, we're looking for this distance right here, aren't we? Would you agree with that? Okay. Well, guys, don't we need to know the distance from here to here and from here to here? T to U and S to V. Would you agree with that? Okay, so let's talk about this distance from S to V first. Okay. Now, I don't know how technical they're going to get with this. I would have to look in the text and see, but talk to me, kids. We're going from 0, 6, and we're going down. Now, kids, you got to be careful on this scale because it looks like to me, guys, you see where this 4 is right here? Oh my gosh. Let me look at this. You see where this 4 is right down here on the scale? But there's only 2 blocks accounted for to get over to 4. So each block is how many units wide? 2 units wide. So guys, here, if each block is 2 units wide, what distance did I go down right here? 4 and then over what? So SV is going to equal, can I say the square root of 4 squared plus 2 squared? Is that okay? You guys good with that? Okay. So help me out, kids. That'll equal the square root of what? Okay. Then we also need to find the length from T to U So I'm looking for this other part right here that's in there. So guys, to go from 810 to 12.2, first of all, understanding that we're going by 2 units every way, how far down and how far over do I have to go for TU? So you're telling me TU is equal to the square root of which is the square root of what? Would you agree with that? This is where things are going to be a little tricky. Radicals. Okay. So right here, kids, I'm gonna say this. Wouldn't we have to add those two sides up and then divide by 2? Now your calculator could do that as a decimal, couldn't it? Okay. Now there's another way I could have done this too, and I'll show you this here. But guys, wouldn't this point and this point right here have to be a midpoint? Okay. I'm gonna make this as easy as I can for you. Okay. The length of the mid segment YZ would have to equal the square root of 20 plus the square root of 80 all over 2. Okay. Now I'm gonna have to do some simplifying of radicals here, guys. How many times would 20 go into 80? Think about this. Could I write the square root of 80 as the square root of 4 times the square root of 20? 4 times 20 would make 80, right? Okay, watch what I do here. But guys, right here, what is the square root of 4? So it's like you've got 2 root 20s right here, don't you? 2 root 20. How many root 20s are over here on the left? 1 root 20 plus 2 root 20s would be a total of how many root 20s up top? You're going to end up with 3 times the square root of 20 over 2. Okay. Now, another way to maybe have done this would have been, guys, take a look at this. Wouldn't your midpoint be here and the other one here? Kids, how far down do I go here? 6, you say? Okay, how far over do I go? Couldn't YZ have also been the following? I've got to think on this here, kids. Because this would have been 4 comma 8. No. Yeah, 4 comma 8. And this would have been from 2, 2 to 12, 2, 7 comma, yep, 3. So 6 and 3, right? Oop, didn't want to do that. Guess we're happy about this problem, right? This would have been a 6 and this would have been a 3, right? So it could have become the square root of 6 squared plus what? Okay, which was equal to the square root of, I don't know, what's 6 and 6? 36. 3 and 3 is 9. So square root of what, 45? Okay. Now, I'm not going to get too fired up about this. If we want to turn stuff to decimals, let me just jump into a calculator here real quickly. Let me go square root of 20 times 3 and divide it by 2. What value do you get about there? 5.97. Same thing here. If I went the square root of, what was it, 45? Something's not working out here. But 3 root 20 over, oh, I think I forgot to divide. Okay, so the square root of 20 first, right? Times 3, divided by what? 6.71 about, right? Wasn't that the same thing as the square root of 45? Worked. Either one would work, right? Okay. All right. So again, kids, are you okay with that? All right. Any questions so far? All right. Let's move to that last page here. Finish up here. Some kite theorems, kids, and we'll just look at something in example 5 and 6, and we'll be good to go. Okay, kite diagonal theorems. If you have a kite, if a quadrilateral is a kite, the diagonals are, what's the word here? Meaning the angles in the middle here have to form what angle? Right angles. And it also says kite opposite angles theorem. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Notice in this right here, C has to be congruent to what? But B cannot equal angle what? Okay. So let's look at this down here in example 5. It says, hey, angle E is showing up here. You've got 115 and 73. All right. Thank you, Alexa. Okay. What two angles have to be the same in here? D and F. Okay. You know a four-sided figure is going to add up to how much? Okay. So what must be true? How are you going to find angle D, I guess, is the question. 115 and 73 is 188 when I add those two up. Which is 172. And that's going to turn out to equal, anybody know it? With me on that? Okay. Give the most specific name for the quadrilateral. What's ABCD look like? Looks like a square, but can I prove it's a square? Wouldn't the diagonals have to be exactly the same in the square? So can that be a square? No. Could it be a rectangle? Because the diagonals would have to be exactly the what? Okay, by those tick marks, they're not the same. Okay. But do those diagonals cut each other in half? They do. And the only kind of thing that I can say here now is this could be a parallelogram. Okay. Guys, the only thing you can say about the next one is that it's what kind of shape? How many pairs of parallel sides you see there? Okay, so this has to be a what? Trapezoid, doesn't it? It's not going to be isosceles because the base angles are going to be very different in this. Those triangles don't match up with each other, so just trapezoid is all I can say there. All right. Okay, kids, what questions do you have for me right now? Stop